All right, we're going to meet an animal that's native to Alabama. And it is a reptile that a lot of people say carry their house around on their back. Can you guess what it is? It's an aquatic turtle. So I have a yellow-bellied slider. This is Leonardo. And Leonardo gets his name because they have a yellow belly. And if they're out of the water, basking in the sun, and somebody comes along and scares them, they slide backwards into the water. So yellow-bellied slider. Now, they do live in the water, but like I said, they do come out of the water to bask in the sun. The reason why reptiles are cold-blooded, so they have to use the sun to warm their blood up. Now, turtles have an excellent defense mechanism. So they have this shell right here. So they can put their arms, you can see Leonardo has his arms, the one's kind of coming out, their legs, their head, their tail, inside of their shell to protect themselves. Perfect defense mechanism. Now, a turtle shell does grow with them, so you can't take them out of their shell. Their backbone is attached right here. This top part is called the carapace. The bottom part right here is called the plastron. And again, their shell grows with them. So yellow-bellied sliders have along their shell, these are called scute scales. And as they get bigger, their scute scales push away to make room for the new scute scales. And actually, Leonardo is going through a little bit of a shed, so you can see his scute scale is starting to kind of pull away to make room for the new one as his shell grows. Now, turtles are omnivores. That means they eat fruits, vegetables, and meat. He loves goldfish, and I don't mean goldfish crackers. And he loves turnip greens too. You'll also notice that he has these claws right here. He'll do a lot of digging with those. And when it gets cold here in Alabama, they will actually hibernate or sleep through the winter until it warms back up. Amazing. Their lifespan is between 25 and 50 years. So they have a pretty decent lifespan. And as you can see, they get rather large because he's not even full grown. He has more growing to do. All right, let's learn some fun facts about turtles. Turtles have lungs and they breathe air. So how is it possible for them to survive in a frigid pond with a lid of ice that prevents them from coming up for air? The answer lies in the relationship between body temperature and metabolism. A cold turtle in cold water has a slow metabolism. The colder it gets, the slower its metabolism, which translates into lower energy and oxygen demands. When turtles hibernate, they relied on stored energy and uptake oxygen from the pond water by moving it across body surfaces that are flush with blood vessels. In this way, they can get enough oxygen to support their minimal needs without using their lungs. Turtles have one area that is especially well vascularized: their butts. Yes, turtles breathe through their butts when they hibernate. The technical term is cloacal respiration. As humans, we breathe in air, which contains oxygen. Oxygen is essential for us and all other animals to survive. Once we breathe in oxygen, our body uses it, and when we exhale, we produce carbon dioxide, and that's released back in the air. Plants such as trees, on the other hand, can take in this carbon dioxide, which is unusable for humans, and use it to produce their own energy. Carbon dioxide, the same gas that you exhale, freezes at 123 degrees below zero. As it freezes, it changes from a gas to a solid. And that solid is called dry ice. It's called dry ice because you don't use a liquid to make it. It's made out of carbon dioxide. So let's have a look at what dry ice looks like. Here we go. All right, you can see immediately that it's quickly turning back into a gas, from a solid to a gas. This process is called sublimation, when a solid turns into a gas. Now, if it was an actual ice cube made from water, when you take it out of the freezer, it goes through a process called melting. That's when a solid turns into a liquid. This process is sublimation. Now, I actually have something here I want to show you guys. So I'm going to put my dry ice here on my table. And I have some tongs right here. And I'm kind of holding on to them to warm them up a little bit. So it's going to be kind of interesting when I actually touch this metal to my dry ice that's going through that sublimation process. So clearly, this is 123 degrees below zero, heating up right from there. And this is like room temperature, maybe a little bit warmer. Let's see what happens when I pick up the dry ice with these tongs. Oh, wasn't that an amazing sound? So what's happening as you take these tongs that are a little bit warmer and you touch them to that super cold surface, it starts to kind of vaporize the dry ice. And as it does, it causes this metal to vibrate. Since it's vibrating, it's creating sound. And so that's the sound that you heard. But then you noticed after a little bit, the sound stopped. What possibly happened to change that? You're right, the tongs reached the same temperature as the dry ice. So it stopped that vibration, stopped the sound. All right, now dry ice, when you put it in water, speeds up that sublimation process and also just looks super cool. So I have a large graduated cylinder right here. And what I'm going to do is take some warm water and pour it into my graduated cylinder. All right, and then I'm going to turn this so you can see the whole thing. All right, you have a nice view of the entire graduated cylinder. And by the way, I'm wearing gloves because things that are super cold can burn you just like things that are hot. So I want to protect my hands from the temperature of the dry ice. All right, so we have our graduated cylinder. We've got some warm water. We're just gonna put just a little piece here of our dry ice into the water. Now, isn't that cool? And especially a very cool sound, right? So the temperature change with the water and the dry ice, it's gonna speed up that sublimation process. And as it turns back into a gas, it bubbles a whole bunch when you put it in water. Just looks super, super cool. All right, so I want to change it up even more. So I happen to have this very strange looking tube right here, or jug, I guess. Right? And I'm going to pour from my graduated cylinder, my dry ice, my water, everything into this container. There we go. And I actually want to add a little bit more dry ice to get this really going. There we go. Now I also have a lid that goes with this. So you'll notice I have a tube that's running from my jug all the way down here. And really nothing too exciting is going on. But what I want to do now is put the lid on my jug. And let's see if we have a change. We do. So right over here, I also have some soapy water. Okay, so really it's just water and then dish soap that I have. I'm going to put the lid on tightly here. All right, since our carbon dioxide is sublimating and turning back into a gas, that means if I stick this right here in that soapy water, I can make something called boo bubbles. This is another way to prove that the dry ice is turning back into a gas because I can blow bubbles as it sublimates. I think what would be fun is to catch one with my glove on here. It's so much fun. Boo bubbles! How much fun is that? So that is some things that you can do with frozen carbon dioxide. The same gas that you exhale every time you breathe, and the same gas that our plants and trees need to thrive. Until next week, have a wonderful rest of your day and keep reading.